This video is about to review calculator-based vector questions. The points A, B, and C have the following position vectors with respect to an origin O. Find the vector equation of the line AC. We do know vector equation equals vector A plus lambda vector B. Vector A is a position vector, and vector B is a direction vector. So first step, let's work out vector B equals vector AC equals position vector C 1, 3, 3 minus position vector A 2, 1, negative 2. Change subtraction into addition, then change the sign. Equals negative 1, 2, 5. So the vector equation of the line AC, vector R equals, this vector R equals x, y, z, stands for all the position vector on the line or on the plane. So the vector equation, vector R equals, position vector, we can use either A or C. Let's use A, 2, 1, negative 2, plus lambda, negative 1, 2, 5. Let's go to B. Determine whether or not the lines OB and AC intersect. Let's write down the vector equation for OB. Let's label this is R1 equals. We will use origin as a position vector plus t times direction vector is OB 2, negative 1, 2. For line AC, let's write down vector R2 equals 2, 1, negative 2 plus lambda negative 1, 2, 5. We will change each vector equation into parametric form. X equals 2t, y equals negative t, z equals 2t. For line AC, x equals 2 minus lambda, y equals 1 plus 2 lambda, z equals negative 2 plus 5 lambda. Then we will set up these two parametric form equal to each other. We got 2t equals 2 minus lambda, negative t equals 1 plus 2 lambda, 2t equals negative 2 plus 5 lambda. Let's label equation 1, 2, 3. We will solve the system equation formed by 1 and 2. Let's go to calculator. Go to menu, 3, algebra, 7, solve system of linear equations. Enter. It's two equations, x for t, y for lambda. Enter. Type in the equations, then enter. T equals 5 over 3, lambda equals negative 4 over 3. Then we will substitute t equals 5 over 3 and lambda equals negative 4 over 3 into equation 3. 2 times 5 over 3 equals negative 2 plus 5 times negative 4 over 3. Go to calculator. 10 over 3 equals. We got negative 26 over 3 on the right side. A contradiction. So line OB and line AC do not intersect. Let's go to C. Find the Cartesian equation of plane pi1, which passes through C and is perpendicular to OB. Let's talk about the formula. Vector R means any position vector on a plane or on a line. This normal vector equals A, B, C. And A is the position vector on plane pi. And this D equals vector A dot normal vector N. And vector R dot normal vector N equals AX plus BY plus CZ. So how to work out this D? Position vector A dot normal vector N. Therefore, in this question, OB is a normal vector. A, the position vector in this situation is 1, 3, 3. So we can write down vector R dot normal vector N equals position vector A dot normal vector N. X, Y, Z dot 2, -1, 2 equals vector 1, 3, 3 dot vector 2, -1, 2. Simplify. 2x minus y plus 2z equals 1 times 2 plus 3 times -1 plus 3 times 2. Final answer. 2x minus y plus 2z equals 5. Let's go to D. Show that the line lies in the plane pi1. We got pi1 2x minus y plus 2z equals 5. Remember, when you see this vector equation of a line, normally we will change this into parametric form. X equals 2 minus lambda, y equals -5 or plus 8 lambda, z equals -2 plus 5 lambda. We will substitute this x, y, z into this equation of the plane pi1. Let's use the left side. Equals 2 times 2 minus lambda minus -5 or plus 8 lambda plus 2 times -2 plus 5 lambda equals 4 minus 2 lambda plus 5 minus 8 lambda minus 4 plus 10 lambda equals 5. Right side also equals 5. So the line is in the plane pi1. Let's go to E. The plane pi2 contains the points O, A, and B, and the plane pi3 contains the points O, A, and C. Verify this vector is perpendicular to the plane pi2. Suppose this vector n is a normal vector to the plane pi 2. We do know vector OA and OB are in the plane pi 2. Then vector OA is perpendicular to normal vector n. Then we can get vector OA dot normal vector n equals 0. Also, vector OB is perpendicular to normal vector n. Then we got vector OB dot normal vector n also equals 0. In other words, if you want to verify this vector is perpendicular to the plane pi 2, you just need to find two intersected vectors on the plane pi 2 and verify this vector is perpendicular to those two vectors on the plane pi 2. So we just need to check this vector 0, 4, 2 dot vector OA 2, 1, negative 2 equals 0 plus 4 plus negative 4 equals 0. And vector 0, 4, 2 dot vector OB 2, negative 1, 2 equals 0 plus negative 4 plus 4 equals 0. Therefore, vector 0, 4, 2 is perpendicular to pi 2. F, find a vector perpendicular to the plane pi 3, which means we are looking for normal vector of pi 3. Let's label as vector n3 equals vector OA cross vector OC. Vector OA 2, 1, negative 2 cross vector OC 1, 3, 3. So we get 1 times 3 is 3. Remember, minus. Negative 2 times 3 is negative 6. Then negative sign. 6 minus negative 2 times 1 is negative 2. 2 times 3 is 6 minus 1 times 1 is 1. Simplify. 9, negative 8, 5. Let's go to G. Find the acute angle between the planes pi 2 and pi 3. We know normal vector of pi 2 equals 0, 4, 2. Normal vector of pi 3 equals 9, negative 8, 5. So cosine theta equals acute angle, we will put absolute value 0, 4, 2 dot 9, negative 8, 5 all over square root. 0 squared is 0, 4 squared plus 2 squared times square root. 9 squared plus negative 8 squared plus 5 squared. Let's go to calculator. 22 for the numerator. Square root 3400. Then theta equals inverse cosine of 22 over square root 3400 equals, we got 67.8 degree. Let's go to H. find the shortest distance from point B to the plane pi 3. We got normal vector of pi 3 is 9, negative 8, 5. And point A and C on the plane pi 3. So R dot normal vector N3 equals position vector A dot normal vector N3 x, y, z dot 9, negative 8, 5 equals, let's use OA as the position vector. So we got 9x minus 8y plus 5z equals 0. In other words, this D equals 0. Shortest distance x0, y0, z0. We will use this formula. Absolute value of ax0 plus by0 plus cz0 minus d all over square root a squared plus b squared plus c squared equals 9 times 2 minus 8 times negative 1 plus 5 times 2 all over square root 9 squared plus negative 8 squared plus 5 squared 2.76. Let's go to I. Find the acute angle between the line OB and the plane pi 3. I. Find the acute angle between the line OB and the plane pi 3. We got the normal vector N3 of the plane pi 3. We can figure out this theta between normal vector and the direction vector of the line OB. Then the angle between the line and a plane pi 3 alpha equals 90 degree minus theta. So we will work out cosine theta first. Then do the substitution. 9 negative 8 5 dot 2 negative 1 2 over square root. We already figured out absolute value of normal vector N3 is 170 times square root 9. Then equals 36 over 3 square root 170. So theta equals inverse cosine of 36 over 3 square root of 170. You don't need to reduce 36 and 3 because calculator will do the work for you. Then alpha equals 90 degree minus theta equals 67.0 degree.